Hello friend, welcome to edenbrain.com. Today we'll see how to construct DFA because DFA construction is little bit complex and an interesting job, I can say. So let's say the question, first question, construct minimal DFA, construct minimal DFA that accepts all strings of zeros and ones, including epsilon. So now let's try to understand this question first of all. So this is a question. It says that construct a minimal DFA that accepts all strings of zeros and ones. So there are two things very clear here. One thing is a minimal DFA. Minimal DFA means minimum number of states, right? So minimum number of states you must draw, right? And then it says zeros and one means the input alphabet sigma will be 0 and 1 means a binary system, you can say. So it's a binary system. And it says including epsilon. Now what is epsilon? Epsilon is a valid zero length string, we can say. It's a valid zero length string, right? Now let's try to see how to construct a DFA first of all. So one hint I will give you. One hint to draw a DFA is whenever there is a epsilon, you have to accept epsilon, then the start state, if epsilon to accept, then start state must be a final state. Start state must be a final state. I hope this is very clear. So this is hint. You should remember this hint, right? So yes, our language also want epsilon. So what I will do, I will draw a DFA where the first state will be the final state, right? So this indicates the first state and this two circles indicates it's a final state 2. And let's give the name to this state as S1. Now yes, it means it accepts epsilon, right? It means it accepts epsilon. Now, but our language says, or our DFA says, it accepts all the strings including epsilon, means now all the strings of zeros and one should be accepted, like 0 should be accepted, 1 should be accepted, 0 0 should be accepted, 0 1 should be accepted, 1 0 should be accepted, 1 1, like this all the infinite strings should be accepted and including epsilon. So this I will call as a language. Okay, now so this is the language which I really want to accept, and this is what accept epsilon only now. So how to accept 0? I will just put a loop of 0. So it means I will accept 0 1 time, 0 2 times, 0 3 times, like that. Similarly, I will say I want to accept 1, then 1 2 times, 1 3 times, like that. So it's a loop of 0 and 1. Now how to formulate 0 1? So this is loop, means I will go n number of times. So here n is 2, which is the size of the string. Now size of string is 2. So first time I will take 0 and next time I will take 1. So yes, I can accept 0 1. Now let's say if I want to accept 1 0, first time I will take 1 and next time I will take 0. Yes, so that way I will accept all the strings of 1s and 0, and this is what the final automata or a final DFA I can say. So this is a final DFA, right? Now apart from this, now what I can enhance this problem is, so this is a problem, this is the answer of the given problem. But now if I say, instead of including epsilon, if I say the next question which is excluding epsilon, then it means a language will consist of 0 1 0 1, like this, right? It means a language will never consist of epsilon. So if you really want to exclude epsilon, again a hint, to exclude the epsilon, the start state should not be final state. So start state should not be final state if epsilon is not accepted. If epsilon is not accepted. Understood? So it's very simple. So it means now I will be having a start state. I will call it as S1. Now this is not a final state for sure. Okay. But it means it doesn't accept epsilon. Doesn't accept epsilon, right? But I really want to accept 1 0. So what I will say? Yes, I want to accept 1 0. So I will say yes, I want to accept it, and that's why I will go to the final state, and let's say that is called as S2. Understood? It means 0 is accepted here, because by reading 0 on S1 I am going to the final state. Now what about 1? Am I able to accept only 1? Yes, you can say comma 1. It means I can accept either 0 or 1. So yes, 0 or 1 is accepted. Now what about 0 1? It means after considering 0, am I able to accept more strings? As per this condition right now I am not able to accept more strings. So what I will do is, first of all, how to check your answer is valid or not? It's not a DFA first of all. So it's not a DFA. Why it is not a DFA? Because every state must consist of the transition of 0 and 1. Understood? So for DFA, it is compulsory to have only one transition of each input alphabet, right? Now on S2 you can see that I don't have any transition of 0 and 1. That's why it is not DFA. I can call this as NFA then, but I want a DFA, understand? So I want to construct a DFA. So what I will do is I will try to add more transitions here. So I want to accept, let's say 0 0. As per my condition, as per my diagram, you can see that only 0 is accepted and next 0 is not accepted. So what I will do is I will keep a loop of 0, right? Yes, so it means 0, 2 zeros are accepted. If I want 3 zeros, yes, it is also accepted. If I want 4 zeros, it will be accepted, because loop will be an infinite number of times. You decide how many times you want to loop, right? And then similarly, I want to accept 0 1 1 1 like this. Yes, it can be accepted, provided you say comma 1. It means now 0 is accepted at the start, and then all 1s are accepted here. Yes, so this is also a valid string which is accepted by a DFA. Understood? Now it is a DFA. You can see that on S1 there is a transition of 0 as well as there is a transition of 1, right? And on S2 you can see that there is a transition of 0 and there is a transition of 1. Hence this is the required DFA, I can say that. Understood? Yes. And one more note here you can mention, I will mention one more note here. The note is to accept n length string, to accept n length string, we require minimum n plus 1 states. So to accept 1 length string, to accept 0, to accept only 0 is 1 length string, we required 0 plus 1 means 2 states. Understood? Okay. Now let's try to see how we constructed this, including epsilon and excluding epsilon. Now in including epsilon, I have the minimum number of states because it's a minimal DFA, and the input alphabet should be 0s and 1. Let's say whether it's a valid or not. Yes, it is a valid. You can see that this is the final required DFA. So this is a machine. I will call it as the required machine. So this is a required machine, right? And now here I have excluding epsilon. Now in excluding epsilon, the first state should not be final state, and that denotes it never accepts epsilon, right? And yes, so this is how it should work. Now one more thing I want to talk about is, can I draw this machine? So let's see the including epsilon thing. So can I draw a machine like this? Instead of drawing like this, can I draw S1 is a non-final state, then I have epsilon, and then I will say a transition of 0 and 1, and then it is. So is this machine and this machine is equivalent, or rather are really is it correct one? The second machine, I can call this as M2 and this is M1. So is M1 is correct or M2 is correct? Now I can say that M2 is not correct because on transition lines, only input alphabets must be there. Only input alphabets must be there. Epsilon is not a valid input alphabet. Only 0 or 1 is the valid input alphabet. So yes, this machine is not correct. I can rather call this as epsilon NFA, but this is not a DFA. Understood? This is not a DFA. This is epsilon NFA. So the question is for drawing a DFA, understand? So that's why this will not be the correct machine. So M2 is not a correct machine, right? Thank you very much.